Good day, everyone. Thank you for joining me today. I am Sachin Gunpat. I will be presenting to you today on the removal of nitrate from wastewater using our BioNext technology. So the first question is, what are nitrates? Where does it come from? And why would you remove it from your wastewater? Nitrate is actually a global serious problem. Normally, nitrate comes from the blasting activities, such as from coal mines when blasting occurs. Ammonium nitrate is distributed in the environment. This normally happens in uncontrolled blasting. What happens thereafter is nitrate or ammonium nitrate leaches into aquifers or nearby groundwater and then contaminates those aquifers. Those aquifers then end up in rivers and ponds where eutrophication takes place. What is eutrophication? It's basically algal bloom. So looking at my screen, you look at the picture there with the guy in the water. All that you see on top is algae, and that's normally due to ammonium nitrate or ammonia and nitrate contamination in the water. Globally, the World Health Organization has set a discharge limit of 1 ppm in groundwater and in nearby rivers. The reason for that 1 ppm level is because anything higher than that is seem to cause blue baby syndrome, whereby the babies who drink this water are restricted with oxygen, and then that turns their lips blue. So therefore, there is a big requirement for the removal of nitrogen or nitrate from the water. Us at Multotec, we are in partnership with Cleantech Water, who's an Australia-based company. We offer two main products for nitrate removal in wastewater. The two products, one of which is BioCleanse and the other which is BioNext. The BioCleanse product is basically a biological technology which encapsulates microorganisms in a PVA gel carrier. So this maximizes the diffusion rate and protects the bacteria from harsh saline conditions, enabling high nitrification and denitrification activity. The BioNext system has a smaller footprint due to the high activity and lower OPEX and lower waste volumes compared to your conventional treatment processes. Our BioNext process integrates both CIF, which is continuous ionic filtration, which is another product within our umbrella. It basically uses ion exchange with BioCleanse to remove your nitrate from your water. The benefits of this is that you also get a low OPEX and low chemical usage. Additionally, your salt intake for your ion exchange is reduced. So those are our two technologies that we do offer for nitrate and ammonia removal. So let's take a look further into the capsule. What you see in front of you is a diagram of a gel-like capsule where you would get bacteria encapsulated. The capsule is more like a contact lens, and inside that contact lens, you would find porous medium where the bacteria do live. What this does essentially, because you're encapsulating that bacteria, you protect it from the harsh environment. So for example, if I had water with very high salinity, maybe around 50,000 ppm, I wouldn't be able to use that in my traditional conventional treatment processes. The reason is the traditional processes allow the bacteria to be in contact with the environment. However, our technology, we protect the bacteria, thus allowing it to thrive in that capsule. And because it's permeable, all toxins, all contaminants enter the bacteria, the capsule, and then is removed thereafter. So taking a bit of a closer look of the capsule itself, you would see that The lens is comprised of a PVA outer skin, which is basically a membrane. And this picture B, you'll be able to see the porous structure of the top layer of your capsule. So the capsule is, as I said, porous. So therefore, you will see many pores, which is microscopic. So these are generally controlled during manufacturing so that we do allow the population to first thrive in there, and thereafter we form the outer layer. So let's look a bit closer of what I've been talking about. What is nitrification, or rather denitrification? So denitrification is a process of converting nitrate into nitrogen gas, which the biocleanse bacteria, this occurs normally in an anoxic environment. Basically, the oxygen levels are very low, so the nitrate becomes the primary source of nutrients, or the primary substrate for the bacteria. When the bacteria break apart the nitrate, it's first reduced to nitrite, which is NO2. Thereafter, it's converted into nitrogen gas. We do have to add a carbon source for the bacteria, as that's what they use for food to grow. A carbon source such as methanol or acetate is generally used. However, if there are organics such as simple chain organics in the water, that can also be used as a food source. So what you see here, that's a typical GA, well, a picture of what the biocleanse reactor would look like. As you can see here, we have the organic substrate, which I said it needs to feed the bacteria for it to grow. We have the influent coming in, and then your effluent going out. In the tank itself, you would have your biocleanse medium. And before it exits the tank, or rather the liquid exits the tank, you would have some sort of moving screen to separate the bacteria, or rather the lens, from the water, so that you don't have any carryover of the bacteria into your effluent. Comparing our technology to traditional biological treatments. So your traditional biological treatments is MBBR, IFAS, MBR. Those are what you would use in industry for removal of nitrates and ammonia. So the difference between biocleanse and these typical medias is the encapsulation process itself. So in the MBBR, which is moving bed bioreactor, you would get a carrier that exposes the bacteria to the environment. So because it's exposing it to the environment, you cannot run it in very saline conditions, and you are limited to your pH range. It's similar with IFAS, the integrated fixed film activated sludge reactor, whereby you do recirculate your sludge back into your primary mixing tank. The problem with that is that it's the same as an MBBR, whereby your bacteria is now exposed to the harsh environments. We can also use reverse osmosis and traditional fixed bed ion exchange to remove nitrate and ammonia. However, the problem is that it produces quite a large amount of waste. For example, with the RO plant, you're looking around 20 to 15% waste. And maybe with the ion exchange, you can go higher, up to 95%. But rather, with our technology, we can actually get to a net liquid discharge. A zero net liquid discharge. So is the slide shows that the comparison between MBBR and our technology. So in MBBR, you would see that our technology actually has 3 times the removal capacity of the same size reactor of an MBBR. And in addition, it does use 3 times lower oxygen content than an MBBR. So that means you are saving on space because you would have a smaller tank, and you save on energy consumption due to the lower oxygen or aeration capacity required. So that's it for our bio cleanse, right? Thereafter we come into our BioNext product. So BioNext is basically a combination of continuous ion exchange and our BioCleanse product. In the BioNext process, we couple continuous ion exchange, as I said. This allows us to reach a product water nitrate concentration of below 1 ppm continuously. So the unique concomitant movement of the resin, it basically ensures minimal fouling is found on, for example, if you want to remove nitrates before an RO, you have minimal fouling on your RO processes. The cleanse is also filtered before you purge, which means that whatever water that you purge will be clean. So basically what this means is to prevent nitrates from accumulating in the system, we purge 1% of the feed. So that 1% can actually be blended with the product water as well, which depends on what are we achieving and what is the discharge compliance required. Or if there is an existing other water treatment system or wastewater treatment system, it can be sent there. Essentially, that will regard the system as a zero liquid discharge system. We also minimize our salt consumption in our ion exchange process. This is due to the fact that we normally use salt, which is in sodium chloride, to absorb the NO3, but because we are continuously recycling, that desorption circuit will allow the salt to be within that system continuously. Hence, we will only top up the sodium chloride rather than in a fixed bed where you continuously have to add sodium chloride. Here we can see a typical BioNext system. Up front, you'll see our CIF or continuous ion exchange, ionic filtration system. So that's normally in vessels where you would have a desorption stage, absorption stage, and wash stage. The concentrated brine is then sent to our BioCleanse system. So the systems are generally in series, or depending on the influent water, can be a single tank. We use low shearing mixes just so that the lens does not get damaged. Other items which you might find around the pump is tanks, pump head systems, and a fully automated control room. Basically, all instruments on the plant allow it to be automatically controlled so that no human intervention is required. We do currently have a system being operated in China. So this system is a 12 megaliter per day system. So initially, the client was struggling to get their total nitrogen down to 1 ppm. Total nitrates down to 1 ppm because they had a traditional wetland treatment plant. Once we implemented the BioNext system, the client actually found that they were continuously getting below 1 ppm of total nitrates in the discharge water, which for them was ideal because they did not get further fines on their side. So the previous plant that I've just shown you was actually built based on previous pilot testing done. So you would see on my screen, this was a pilot test also done in Taiping in China. We ran two reactors in series with a continuous influent concentration of 20 ppm nitrate. As you can see, the effluent concentration, which is in orange, remained at 0. So where you would see the spikes, that's basically during the maintenance phases. So we used for regeneration, we used a concentrated brine because this was a CIF process. Hence, we also reduced the salt concentration used for regenerating the ionic process. Okay, this was on the same test done. As you can see, we can continuously remove the 20 ppm, which can be reused for regeneration of the media. we did have to control, you would see at day 15, what happened was, you have to control your carbon and nitrogen dosing ratio in the reactor. But after we did get it right, we did see good results on the reactor. And therefore, we use these results to upscale it to the 12 megaliter per day system. This is the fully implemented system. On the right, you would see the 3D layout, and on the left, this is a fully designed and upscaled system. So what are the benefits of BioNex? BioNex, we can offer you up to 99% recovery compared to your RO and ion exchange plants, which can offer you way less. We can provide up to a zero liquid discharge system. Basically, you can put the 1% of the brine into an evaporation pond, and then that will allow us to get to a zero liquid discharge system. Additionally, it can handle quite high saline environments, and that also allows it to be applicable to many ranges of wastewater, and we're not restricted to just a specific set of wastewater. We do also reduce the capex for about 90 to 95% specifically on salt addition. That's due to the recycling effect of the salt within that stream. Okay. Just before I can go, just want to give you a brief operating window of the two. What is the differences? So the BioCleanse, we can do both nitrification and denitrification. Temperatures are generally between 15 and 30. You can go below 15. However, what you would get is a longer seeding time for your bacteria due to the harsh conditions, but it can achieve that lower temperature, roughly around 10 degrees. With a TDS, as you can see, we can do up to 5% TDS, just the BioCleanse, and up to 1% for the BioNex system. The influent quality, we can do up to, well, basically whatever your wastewater has, we can treat with the BioCleanse. However, with the BioNex, we are limited due to our ion exchange capabilities of 200 ppm. All right. All right, and then the flow rate for the BioCleanse, you have, we can actually do up to any flow rate that you require. However, with the BioNex system, again, we are restricted by our CIF technology, which can give us up to 100 meter cube per hour. Thank you very much for allowing me. Just before I let you go, please note that Multotec offers a wide range of water treatment solutions. We generally would bespoke a system for you. We do pilot testing right up to execution and installation and commissioning. So please, if you have any questions, feel free to chat to me.